Amazon Relational Database Service, or RDS, is a fully managed cloud solution engineered to host standard relational engines using SQL, including Postgres, MySQL, Oracle, and SQL Server. When you provision a database directly on standard EC2 hardware, your engineering team owns the entire operational lifecycle. You are responsible for installing operating systems, scheduling engine updates, writing custom backup scripts, and constantly monitoring storage volumes to prevent disk starvation. RDS absorbs that operational overhead. AWS establishes a secure administration boundary around the database, automatically handling OS patching, database software maintenance, and continuous backup streams. These continuous backups capture the transaction log, allowing you to execute a point-in-time restore to any specific second within a retention window of up to 35 days, without relying on manual snapshot agents. To provide this level of strict automation, RDS requires a total administrative lockdown. You forfeit all SSH access to the host machine. You cannot log into the underlying operating system, compile native engine extensions, or run legacy background daemons. If a relational database completely exhausts its available disk space, the engine halts. Write queries are blocked, and existing database files can corrupt, causing total application outages. This live telemetry chart tracks database capacity usage over time, mapped against the underlying EBS storage volume. To prevent storage starvation, RDS relies on a mechanism called storage auto scaling. AWS prevents rapid, costly scaling loops by enforcing 3 strict mathematical triggers before resizing a volume. First, the unallocated database storage must drop below 10% of your total allocated capacity. Second, this low storage state must persist continuously for exactly 5 minutes, filtering out transient capacity spikes. Third, at least 6 hours must have elapsed since the last block storage modification. This accounts for AWS block storage fabric limitations, which require a physical cooldown phase between resizing operations. Only when all 3 criteria are met simultaneously does RDS initiate a physical resize, seamlessly expanding the EBS volume to a larger capacity tier while the database remains online. To prevent anomalous database behavior, like an out-of-control logging loop, from consuming your entire cloud budget, you must define a maximum storage threshold. This establishes a rigid ceiling that blocks further volumetric expansion, forcing engineers to manually intervene and clear storage blocks. Storage capacity is only one dimension of scaling. When a web application generates heavy, continuous query traffic, you need to scale database read performance. RDS handles this horizontally through read replicas. You can deploy up to 15 distinct replica nodes connected to a single master database instance, distributed across local availability zones or separate geographic regions. The communication between the master node and these replicas is strictly asynchronous. When the master receives a write transaction, it commits the data and immediately returns a success signal. Only after responding does it transmit the transaction logs outward to the replica nodes. This asynchronous architecture prevents the primary database from suffering network latency penalties during writes. However, it introduces eventual consistency. A read query routed to a replica might briefly return stale data if that specific node is still catching up. You must also account for the physical transit of these logs. Replication traffic within the same region travels over local infrastructure for free. Cross-region replication moves across the global AWS WAN, incurring standard data transfer fees. Furthermore, read replicas do not automatically balance your traffic. They are independent nodes designed exclusively to handle select queries. To actually distribute the read load, your developers must manually update the application code with new connection strings pointing to the individual replica endpoints. While read replicas effectively scale query throughput, their asynchronous nature means they offer zero protection against physical infrastructure failures. To build a true disaster recovery mechanism, you must implement an RDS multi-AZ deployment. This architecture provisions a redundant standby instance in a completely separate availability zone, connected to the primary database by a dedicated fiber pathway. Unlike read replicas, multi-AZ uses strict synchronous replication. When a write hits the primary database, the primary blocks the outbound application response. It waits until the standby node confirms the write is fully committed to its remote storage arrays. This synchronous handshake ensures absolute data consistency across 2 physically isolated data centers, guaranteeing zero data loss. The cost of this guarantee is a minor amount of write latency added to every transaction. If a localized physical disaster occurs, such as a data center power outage destroying the primary availability zone, AWS automatically detects the loss of the primary instance. RDS resolves the failure automatically by promoting the standby instance to active primary status. Because the architecture uses a single regional DNS connection string, application traffic is instantly redirected to the newly promoted node without any manual intervention or application code updates. There are specific enterprise architectures, typically involving legacy Oracle or Microsoft SQL Server deployments, that strictly require low-level modifications to the host operating system. To accommodate these exact requirements, AWS provides RDS Custom. This configuration removes the standard administrative restrictions, restoring full secure SSH and systems manager access directly to the underlying compute layer. Because manual OS edits can conflict with AWS's internal monitoring agents, engineers must capture a baseline snapshot and temporarily disable automation mode. This pauses automated traffic while you apply custom patches or install background daemons. RDS Custom serves as an architectural bridge. It provides the granular control necessary to run complex, self-managed enterprise software while still leveraging AWS's managed automated backup workflows. Standard RDS environments require you to exchange host-level SSH access for fully automated OS patching and continuous database backups. EBS storage volumes will only autoscale to prevent disk starvation when 3 strict mathematical thresholds, 10% remaining capacity, 5 minutes of continuous low storage, and a 6-hour physical cooldown are met simultaneously. When architecting for performance and resilience, you use asynchronous read replicas to horizontally scale query throughput and synchronous multi-AZ deployments to guarantee survival and zero data loss during physical data center failures. For legacy Oracle and SQL Server workloads that cannot function without root access, RDS Custom provides the necessary SSH tunnel to the host operating system. Mastering AWS database architecture requires selecting the exact combination of elasticity and replication for your specific workload without overlapping their specialized functions. In Part 2 of this masterclass, we will examine Amazon Aurora, exploring its proprietary cloud-optimized engine, peer-to-peer storage fabrics, and global database cloning capabilities. I will see you there.